So far, we've explored equations that perform algebraic operations to produce one or more results. A function is a way of encapsulating an operation that takes an input and produces exactly one output.
Here's a function called f that takes in an input variable called x and returns x plus 2. So if we use this function with an x value of 3 to set the value of a variable called y, then of course y is set to 5. Now we can plot this function to show the output value for every possible input value. In this case, the function is a line in which y is always at the point x plus 2. Okay, let's look at a different function. This time the function is called g, and g of x is 10 divided by x. So, g of 5 is 10 divided by 5, which is 2. However, what happens if we try and use the function with an x value of 0? Well, anything divided by 0 is undefined, so the function is undefined for an x value of 0. Now we call the set of numbers for which the function is defined its domain, and in this case, the domain of function g is defined with x being in the set of all real numbers such that x is not equal to 0. Now less formally, you might see this written in a function definition like this. When we plot this function, the value of y for every possible x is shown, but note that as x gets closer to 0, the values of y never meet, because the function is not defined for an x value of 0. Alright, let's look at another function. Function h returns x squared. Again, let's look at the graph for that function, and note that when you multiply any number by itself, the result is always 0 or greater. You can't square a number and get a negative value. So the possible outputs for function h, which we call its range, is defined as being the set of all real numbers such that h of x is greater than or equal to 0.